let's start with this next example. Let's say I want to integrate 3x plus 1 and to the power square root of 2 dx. Okay? So remember our tips, simplify if possible. There's really nothing for me to simplify. That exponent is not a nice number, so I can't FOIL anything out. What was the second tip? Try substitution. What would you want u to be? 3x plus 1. Usually there's only one choice for what you think u should be. Du is then going to be 3 dx. All right, so now let's plug it in and see what happens. So I'm getting the integral. I'll get a 1/3 u to the square root of 2 du. That looks a little bit nicer, right? Just a little bit. Don't get tripped up by that square root of 2 in the exponent. That's just a constant, right? So you do it's 1 point something, right? So you're gonna do the reverse power rule, just like you would normally do. So I'd get 1/3 u to the square root of 2 plus 1, divide by that number, plus c, and then plug in for u at the end, okay? So 1/3, 3x plus 1 to the square root of 2 plus 1, square root of 2 plus 1 plus c, okay? So like I said, when you're doing these problems, I don't necessarily know every single integral off the top of my head. If you show me a random one, the chances of me integrating it, I mean, they might be pretty good, but there's a chance that I will have no idea what to do. You just have to keep trying until something works, okay? Okay, let's do another one. So let's say I want to integrate t over t to the 4th plus 2 dt. I can't simplify anything. If you did substitution, what would you want u to be?
T plus 2.
Yeah, so let's see how that works out. I don't know. So if I did u equals t to the 4th plus 2, du is 4t cubed. I only have a t, I don't have a t cubed. So this is saying, okay, the substitution isn't going to work. What kind of function do I have in the integral? It's a polynomial divided by a polynomial. It's a rational function, right? And we've been talking a lot about rational functions this past week. We use partial fractions, right? The degree of the top is smaller, so we don't have to divide. Can you factor the denominator?
No.
No, you can't. If you can't factor the denominator, then you can't use partial fractions. Oh no, that was my only idea I had, right? So we got to think a little bit differently on this problem. So let me tell you how to do that. What you're going to do is you're going to think of this integral. You're going to rewrite the denominator as t squared squared. And now you're gonna do a substitution. What is your substitution gonna be? U equals t squared. The derivative of that is 2t dt. So substitution will now work out for us in this problem, okay? And when you do it, you'll get a 1/2 here, 1 over u squared plus 2 du. Now, I know we saw this integral last week. Remember, there was a formula for this integral? What function do I have? 1 over u squared plus a squared, remember that integral? Arctangent, okay? So you're gonna use that formula from class last week to do this one, okay? And that's in the notes if you need it. All right. So again, you just try and try and try, and hopefully something will work out. That's the goal, okay? Let's do another one. Let's say I'm going to integrate e squared dx. Do you have any ideas? That's just a number, right? Don't get confused with the e there. E squared, that's just a constant, right? And we can pull constants outside in front of the integral. So this is e squared, the integral of 1. What's the integral of 1? X, exactly. Okay? So sometimes things can look a little bit more deceiving. Just make sure you're thinking it through. Tell yourself that that's just a constant, and I know how to integrate a constant. Yeah.